Hello everybody, I am back with another video for you. We are about to start a new unit on algebraic expressions. So this is sort of the lead into a little bit of algebra. I guess the first thing we need to talk about is what is an algebraic expression. Okay, and as you can see, I put the definition here for you. This is an expression that contains numbers, operations, and one or more variables. So it has to have these three components. It has to have numbers in it, it has to have an operation, and it can have one or more variables. And we'll talk about that word variables if you are unsure as to what it means here in a second. So the one thing about an algebraic expression is that it cannot have an equal sign. So if I said 3n plus 1, that could be an algebraic expression because it does have numbers in it, it has an operation, and a variable is really just a letter, so it has a letter in it. That would be an algebraic expression. Okay? Another one I could just say as n minus 4. That is also an algebraic expression because, again, it has a number, it has an operation, and it has a variable in it. Another one could just be a and an n. Okay? That could be considered an algebraic expression also. While we don't see the operation, please remember that we've talked about anytime you have a number and a letter together, that means multiply, and also anytime you would have two letters together, that also means to multiply. Okay, so it does have an operation in it. Now, something that would not be an algebraic expression. Okay, let me show you an example of something that would not be. If I just said 5 plus 1, right? That would not, I'm going to put a word not above this here. This would not be an algebraic expression, right? I don't see letters, so it's not an algebraic expression. It has to have these three items here. Okay, this would not be. I could have a 2n plus 4 equals 10. Okay. Another thing an algebraic expression cannot have is it cannot have an equal sign. So because it has an equal sign, it is not an algebraic expression. As you can see in these examples that I showed you, none of these have an equal sign. It can't equal 20 or 40 or whatever. So this is not an algebraic expression. Okay? The number 5 would not be an algebraic expression. We don't see an operation, and I don't see a variable here. Okay? So remember, an algebraic expression has to have three parts: numbers, operations, and variables. Okay, now that we know what an algebraic expression is, we're going to spend some time talking about some vocabulary, because we need to be able to attach some terms to the parts of this expression. So there's 4 terms that we're going to talk about here today: coefficients, variables, terms, and a constant. And we need to know what these words mean and how to pick them out of an algebraic expression. Okay, so that's our goal here for today, is just to work on a little bit of vocabulary. I know oftentimes we don't have a whole lot of vocabulary in math, but today's one of those days that we need to get some introductory terminology down before we go any further. Okay, so let's get started. Okay, if you look at this page, on it are 2 examples of an algebraic expression. Okay, but our focus here right now is the word term. Okay, a term is the parts of the problem that are being added or subtracted. The parts of the problem being added or subtracted. So, if we were asked to pick out the terms of this first expression here, okay, I could say that 5n is a term because it is going to be added to this, right? So 5n is a term, 3 is a term, 4b here is a term, and so is 2. These are all terms because they are either being added or subtracted to another one. It's sort of the parts that are in front of and behind the operation. So if we look, this expression has 1, 2, 3, 4 terms. If it asked you how many, we would say there's 4 terms here. If we look at this one, 9 plus 6y minus 2, we would say 9 is a term. 9 would be considered a term. 6y is a term. And so is 2. Again, it's the part that is in front of the operation and behind. So if they asked you how many terms were in this one, we would say that there's 3. Okay? So terms are the parts of the problem being added or subtracted. So there's one vocab word for us. Let's move to the next one. Okay, our second vocab word is the term variable. And some of you may be familiar with this from previous years because it is a pretty common word, and some of you may not be. But a variable is usually a letter that represents a number. Now, it can also be a symbol, but most of the time we use a letter for this variable. One of the more common ones is people tend to use X and Y because it sort of goes along with a coordinate grid that has X and Y with it. But you can use any letter you want. Okay? I've used a variety in here today just to show you that you can use any letter. But a variable is a letter that represents a number. So in this one, my variables would be N, I'm just going to underline them here, and D. That's the only letters that are in there. There's no other letters. We have a 3 and a 5 and an 8, but they are not letters. So if you were asked how many variables are in this expression, you would be able to say that there's 2. Or if you were asked to underline them or mark it somehow, we should be able to do that also. Okay? When we go to this one, 6s plus 7 minus z plus 3c, we should be able to say that, well, we have a variable of s, we have a z, and we also have a c. So this one has 3 variables to it. Okay, variable is one of the more common terms that you will hear used pretty frequently, but it's a letter that stands for or represents a number. Okay, and it's called variable because this can change. You could make n worth anything. We could make n worth 1, and then this would be 8 times 1, which is 8. We could make it worth 2, which is 8 times 2, and this would be 16. 8 times 3 would be 24. So this can vary. It can change. So that's sort of why it's called a variable. Okay? So we know term and we know a variable. Let's move on to the next vocab word. Okay, our third vocab word right now is called a coefficient. Okay? And a coefficient is the number that is attached, it's usually in front, to the variable. It's the number that's attached to the variable. It's usually in front of it. So in this problem, my number that is in front of the variable would be 9. My coefficient is 9. Just 9, not the letter, just the number that's in front. So if I look at this term does not have a letter, so that is not a coefficient. This one has a letter attached to the number, or a variable attached to the number, So this would be our coefficient of 2. Okay? And this one, again, does not have a variable, so it is not a coefficient. To be a coefficient, it has to be attached to a variable. It's the number that is in front of your variable. So in this problem, this one has 2 coefficients. It has 9 and it has 2. Those are the only 2 coefficients, 9 and 2. Okay, let's look at this one. Well, this has a number in front of the variable, so 6 would be a coefficient. This has a number in front of the variable, so 2 would be a coefficient. And this has a letter. There's no number in front of it, but it is understood that if there's no number there, it's like you have a 1 in front of it. Okay? So in this one, 1 would be our coefficient. We're assuming if there's nothing there, means there's a 1 in front of it. It means you have 1 times D. This one means 2 times B, but when there's nothing there, we assume it's a 1. So this has coefficients of 6, 2, and 1. Again, the 7 here does not have a letter, so that is not a coefficient. It has to be attached to a letter. Okay, so a coefficient is the number that is in front of your variable. Okay, let's move to our last vocab term here. Our last term for the day is the word constant. And if you think of the word constant, constant means something that stays the same. Okay, and that also applies to this algebraic expression. But a constant is a number that is alone or all by itself. So if we look at this, this is not a number alone because it has a attached to it. In this term, 8 is alone. It's all by itself. So we would call it a constant. Right? So 8 is a constant. It's a number by itself. In this next term, 3 and C are attached to one another, so that's not a constant. But 1 is another one by itself, so it is alone. So my constants in this problem would be 8, and it would be 1. Or if it asked, you would say that there's 2 of them. If I go down to this one, I can say that 7 is by itself, so 7 would be a constant. 4 and D are attached, so it's not alone. And 5 is alone, so 5 would be a constant. S is not a constant because it's not a number. It has to be a number. So 7 and 5 here are our only constants. Okay, so we've been through all 4 terms. So we are going to try and put this all together right now. Okay, so we have an algebraic expression up here, 5m plus 4 minus 8v minus 2. So our job here is to sort of pick out some of the terms that we talked, or vocabulary that we talked about here. So the first one wants us to circle all the terms. Okay, so let's think back. Terms were part of the problem that was separated by the addition or subtraction sign. So we could say that 5m is a term, right? 4 is a term. 8v is a term. And so is 2. Those are all terms, right? They're parts that are separated by adding or subtracting. Okay, now we're asked to underline the variables. Remember, a variable is a letter, usually a letter, that stands for or represents a number. So if I'm underlining the M. The M is my variable, and so is the V. So those would be variables. And I think that's all. No, I don't see any other variables. Square the coefficients. Okay, coefficients, if you remember, is the number that is attached or in front of the variable. So it wants me to put a square around those. So there's my variable. This one has a number in front. So I am going to square it. Put a square around it, I guess I should say. 4 is not a coefficient because it does not have a letter. Here's one that does. V has a number in front of it. So this would be a coefficient. And 2 does not have a letter attached, so it is not a coefficient. Okay? And finally, it asks to put a triangle around the constants. Constants, remember, the numbers that are by themselves. So what is by themselves? Well, this 5 is not because it's attached to M. 4 is, so I would put a triangle around 4. 8 is not alone because it's attached to V, but 2 is. So 2 would get a triangle. Okay, so I think we've picked out all the terms, all the variables, all the coefficients and constants. Okay, let's look at another one. Now, I've put circle or underline or square here, but remember, you could be asked to do anything. You could be asked to highlight it. You could be asked to put a squiggly line under it. It could be anything. The point is that you are differentiating between these different vocab words here. So the first one says circle terms. Terms are the part that is being added or subtracted. So there's a term, right? Here's a term. 3, M, and 6A. Those are all terms. Okay, underline the variables. The variables were the letters that represent numbers. So we have a D, I see an M, and I also see an A. So those would be all my variables. Okay, square the coefficients. Coefficients are the numbers in front of a letter. So this would be a coefficient, right? It's in front of the letter D. This would be a coefficient because there is 6 in front of A. And also, don't forget, M has a coefficient in front of it. It has the coefficient of 1. So I'm going to put a 1 there and put a little square around it. Right? These do not have letters, so they are not coefficients. And then finally, put a triangle around the constant. Constant is your number alone. So my number alone would be this, and my number alone would be 3. Okay, great job. Okay, one last way to look at it is maybe you're not asked to circle them. Maybe you're asked to list them. Okay, so let's try one like this. If I'm asked to list the terms, 7 is a term, right? 2D would be a term. 3 is a term. I'm putting commas in between these. M is a term, and so is 6A. They are the parts that are being added or subtracted. In this expression, there's 1, 2, 3, 4, 5 terms. Okay. List the coefficients. Coefficients is the number in front of the letter. So 2, is a coefficient. 6 would be the coefficient. And so would the 1 in front of this M be a coefficient? My constants are the numbers alone. So in this case, it would be 7 and 3. Those are the 2 numbers that are all by themselves. And then finally, my variables, I have a D, I have an M, and I have an A. Okay, so no matter what you're asked to do, whether you're asked to mark them or list them, we should know these 4 vocab words. Okay guys, so overall today was an introduction to algebraic expressions and a little bit of the vocabulary that we're going to use. So let's just quickly review here that coefficients are the numbers that are attached. They are in front of a variable. The variable was a letter that stands for a number. The terms are the parts of the problem being added or subtracted. Your constant is the number alone. And then finally, the big overarching thing we're talking about is algebraic expressions. and they contain numbers, operations, and variables. And I think we saw that today. Okay, so you're going to do a little practice for me here today with picking out some of these things. Please refer back to this video with some of the vocabulary if you need it. Okay, all right, guys, thank you and have a great day.